Right then, I need a plan B. Doesn't involve electrical tape and fire. Good afternoon. I've been working outside today and it's getting very hot at the moment, so I thought I'd come have a look at one of these lights. They're from Aldi and I've got 3. I made a mistake, I bought 2 and I got a black one and a white one. So I went back and bought another white one because I'm going to use these possibly inside for lighting my workbench. I haven't decided yet. So I thought I'd have a look at this black one and we'll take it apart, see what's inside. Probably fairly standard stuff. £7. Been in local Aldi for a few weeks now. It says 220 to 240 volts, 60 Hz, power 10 watts, IP65 rating, and we can see it's a proper ceiling grommet on there. It goes nice and tight. So cable entry gland, looks waterproof. Have a separate panel for the electric connection. Like the Chinese ones, it doesn't come with 4. Off. There we go. Right. It does have a separate rubber seal in there. A bit of copper wire stuck in it. Just aluminium body. It's got a little raised lip there, which coincides with where this rubber seal sits. So that's quite nice. It looks like it'll keep the water out. Normal little connector block in there. Tip: don't put the extension lead on the mouse. We have light. That's quite a nice light. It's not too blue. It is very flickery on the camera though. That looks a little better. Right. So still turn on, just have a quick look at the power. It's showing 19 watts. Interesting. So we'll take a look inside it. So looking at the front, we see 4x3. We've got 12 LEDs in there. So 1 watt each, and it looks like series parallel. Let's have a look. It has a thick glass front. It looks heat treated. Also, it's stuck to this silicon seal. There we go. out of the way. It's a plastic reflector just sat in there. This seal is glued down. You can see a tiny bit of the glue just there. What's that? No, maybe that's just to stop it leaking. Earth is properly bonded. More stray bits of copper wire in there. And the light module says 10 watts. Looks right then, I'm going to re-record this because I edited the last lot together and the audio was just messing up all over the place. So I'm going to try again. I've had to turn the resolution down to 720, but it looks like it might be writing the files out properly this time rather than corrupting them. So here we go. Now, because of the board being white and glossy, it's very difficult to see the tracks, but I'll put a picture in which sort of shows where the tracks are. There's some reflections as well, but you can see most of the tracks. We have the AC mains coming in down here, live and neutral. Nice that it's got a bit of heat shrink tube on just where it passes through the main body of the light there. So live comes up, we have a fusible resistor. Up here, under the MOV, and into the bridge rectifier at the top. Look under there. Yeah, the tracks just come straight up into there, so there's a MOV. Same with neutral. Lots of space around this screw, so it curves around up into the bridge rectifier. Coming out of the bridge rectifier we have a 1 meg resistor across here. That's possibly just to stop flickering, which I have noticed this corner LED was flickering earlier. Not sure what, it wasn't near my phone and don't have any Wi-Fi devices particularly close. That was just with it on the isolated supply on the bench, so it wasn't even on the mains. There's a trace comes down from the bridge rectifier, nice big copper pad here and the same here, but we're going through this LED, through this one, up, across, up, up, across to here, and then to here, down, across, down, down, and then it goes back up to these two end pins of the IC here, which are in common. There are two more tracks that come down, one from just here, that comes down and joins just here between these LEDs, and another one which comes from that capacitor down, joins these two. Off the other side of the bridge rectifier it goes underneath, across the top, into this resistor here, 100 10 ohms, and then from there into U1. So this is in series with the LEDs, So all the current is going through the resistor, through this IC, through all the LEDs, back. Now I've measured this with a plug-in power meter and it was saying that it was 19 watts. It's not. A lot of that is coming from the isolating transformer. I don't think it'll actually draw enough power for the meter to read directly. So let's measure some values on here while it's running. So we have a resistor here in line. There is a trace comes off the bottom, I think. So we have current sensing across this 10 ohm resistor. We can easily get to the terminals here. So if we measure the voltage across the LEDs, which are coming from here to here, and we measure the voltage across that resistor, which we know the value of because it says it's 10 ohms, we should be able to figure out how much power is actually being driven to the LEDs. And at this point I'm going to put in the original bit of video when I first tried this, and I thought I'll put some electrical tape over the LEDs, then it's not going to swamp out. I have a better plan for this video. There we go, blinded. How's that? Oh. Oh heck. The tape's already burning. Right. That gets very hot. It's burnt 12 little holes through that tape. There you go, so hot, so quick. Wow. I wasn't expecting that. Feels cold to touch. Ow, but it is not. They get very, very hot very, very quick. For this video I'm going to use a little piece of cardboard. So volts DC. So power is coming from the top of the bridge rectifier DC side down to the bottom through all the LEDs and then back up here to that IC, and that gives us 171 volts DC across the LEDs. So it's obviously not just 12 of them in there. And the other side of the bridge rectifier is coming across to this resistor here, 10 ohms, so we can measure that. 0.341 volts. So now we can do some maths and find the current across these LEDs. Still very bright. So the resistor we know is 10 ohms. Voltage across it was 0.34. It's very slightly different from the last time I measured. We'll say 0.34. It was 0.339 the first time, so 0.34. So to find the current, we have Ohm's law, V equals IR. We rearrange that. and we get I equals V over R. So I current 0.34 over 10.034 amps. And now to find the power, P equals IV. So power equals 0.034 for the current in amps times the 170 volts that we got across the LEDs. It gives us 0.034 times 170 . 5.8 watts, not 10. Sorry Aldi, you got it wrong. But I imagine they ordered a 10 watt device and that's what they were shown. That's pretty usual for Chinese LEDs. So, I guess, how many LEDs are in there? So 170 volts, and we only have 12 LEDs. .16 volts per package. So if we say it's probably going to be about 2.3 volts for the LED, 6. Volts, 6 chips in each package. If we just do that sum the other way round, 14.167 divided by 6 is 2.36 volts per chip.